Question 2 says, in the diagram, point A and B in the first quadrant are points on quadrilateral ABCD. Equation of line DC is given as y is equals to negative a third x minus 1. DC forms an angle with theta with the x-axis as indicated. So we have theta over there if it is invisible. Determine the size of theta, which is our first question. How would we determine the size of the angle here? So theta is what we call, there's an angle of inclination, then there's an angle of depression. So this will be our angle of depression. Both of these angles, angle of inclination and depression, are supplementary, meaning they add up to 180. So naturally we have this formula, tan theta is equals to gradient, where theta in this form gives us the inclination angle. So I'll replace that with B such that we don't get confused. B here that we are calculating would give us this. But our issue lies within the fact that when we calculate our answer with the negative gradient here, the gradient here is -1/3. The answer that we'll get for the angle will be negative. So that is due to the fact that this formula gives us the angle of inclination. So we would have to subtract 180 from that, because the answer that it will give us would be this one. This formula always returns an acute angle. But if you're not following with what I'm saying, we can just solve the question as follows. So in here, make B subject to the formula, or let's just keep it as theta. Say theta is equals to, take tan to the other side, you get arctan of the gradient, which is -1/3, like that. Then theta would be equal to, if you put this in your calculator, you'd get -18.4. But in this case, you can just take it as positive, 18.4 degrees, like that. So that is the size of the angle over there, 18.4. If we're looking for this one over here, then we would subtract 18.4 from 180 in order to get the angle.